Today we will discuss about synthesis of ethyl acetoacetate. Ethyl acetoacetate is prepared from ethyl acetate. When 2 moles of ethyl acetate are treated with base, like organic base, then it will produce ethyl acetoacetate. Now we'll see the mechanism. Mechanism involves following step. Step 1 is formation of carbanion. When ethyl acetate is treated with base like sodium ethoxide, one of the hydrogen will be abstract by the base to form CH2 C double bond O OC2H5. This is a carbanion. Step 2 is attack of carbanion on ethyl acetate, second molecule of ethyl acetate. So this is the second molecule of ethyl acetoacetate, and this is carbanion. Now this carbanion, which is negatively charged, it will attack on the carbonyl carbon of second molecule of ethyl acetoacetate to form this type of again anion, which is known as oxide ion. To this carbon CH2 C double bond O OC2H5 is attached. Now this oxygen, which is negatively charged, it transfers its negative charge to the carbon, and this will be getting out. So here minus OC2H5 will give actual ethyl acetoacetate CH3 C double bond O. Then this C2H5 we will write here CH2 C double bond O OC2H5. So here actually we will get ethyl acetoacetate, but here base concentration is greater, so we can say we have to acidify this mixture. After acidification, or we can say in presence of H plus, we will get CH3 C double bond O CH2 C double bond O OC2H5. So this is ethyl acetoacetate. So this is a methylene group which is sandwiched between 2 electron withdrawing groups like C double bond O. So this is known as active methylene compound. This active methylene compound, ethyl acetoacetate, is used in synthesis of many organic compounds. Now we will discuss about the ketoenol tautomerism of ethyl acetoacetate. Ketoenol tautomerism of ethyl acetoacetate. Dear student, we have to write ethyl acetoacetate in this form CH3 CH2 OC2H5, or the same we can write like this C double bond O C double bond O OC2H5, or we can write in this form C double bond O we'll discuss about keto-enol tautomerism of ethyl acetoacetate. Now keto-enol tautomerism. So this ethyl acetoacetate we can write CH3 C double bond O, CH2 C double bond O, OC2H5. Now this we can write in this form also, CH2 C double bond O, OC2H5, CH3, or double bond O, double bond O, and OC2H5. Here are two hydrogens. Now one of the hydrogen is transferred here, so it will shows keto-enol tautomerism. So oxygen as this bond comes here, there is a double bond. This bond goes here, so here is a negative charge, and this hydrogen will be abstracted by this oxygen, so here will be H. So this is a keto form and this is enol form. This enol form is more stabilized by the hydrogen bonding. So this is all about keto-enol tautomerism. Now we'll see the applications of EAA, ethyl acetoacetate. First we'll see synthesis of monobasic acid. Monobasic acid is the acid, carboxylic acid, which contains only one COOH group. So here ethyl acetoacetate ethyl acetoacetate C double bond O, C double bond O, OC2H5. This is when treated with base like KOH or NaOH, then one of the hydrogen of this will be replaced by H. H will be replaced and carbanion is formed, and when in the second step we are treating this with alkyl halide like CH3Cl, then one of the hydrogen will be replaced by Cl. So this hydrogen will be replaced by Cl. So we can see here a remaining structure is as it is, C double bond O, OC2H5. This H is as it is, and here we can write CH3. So here CH3 will be attached. Now when this particular compound undergoes hydrolysis, then this bond will be going to break here. So you have to break this bond and this bond, add OH to this side, H to there, OH and H. Then you will get C double bond O, OH plus CH3, CH2, C double bond O, OH plus C2H5OH. So this is nothing but CH3COOH. So we are getting acetic acid as one of the compound. Then this is propanoic acid. So if in this reaction we will take, instead of CH3, if we will take C2H5, then this CH3 will be replaced by C2H5. So here also you will get C2H5. So instead of propanoic acid, you will get butanoic acid. So this type of variety of acids you can prepare by from ethyl acetoacetate. So once again we will revise. When ethyl acetoacetate is treated with base, then this hydrogen will be removed. So when this carbanion is treated with any alkyl halide, then at the place of H, here alkyl group is attached. Now when this particular compound undergoes hydrolysis, so you will get two different acids. One is acetic acid, and depending upon the R group, so we can say here R group, there are different types of monobasic acids we can form. Then synthesis of dibasic acid. So CH3 C double bond O, CH2 C double bond O, OC2H5. This is nothing but ethyl acetoacetate. When it is treated with base, H is removed, and when it is forming carbanion. When this carbanion is treated in the second step with alkyl halide like CH3Cl, H will be replaced by CH3 group, and we will get here CH3 C double bond O, CH3 C double bond O, OC2H5. When this compound again treated with base, and in the second step with methyl chloride or any alkyl halide, then another hydrogen will be replaced by CH3 group, and we will get CH3 C double bond O, CH3, remaining structure as it is C double bond O, OC2H5. When it undergoes hydrolysis, this bond and this bond is going to break. H and OH will be added here. So you will get here CH3 C double bond OOH plus CH3 H, CH3 C double bond O, OH. So here we are producing substituted this is nothing but substituted acid.